I have the pleasure to introduce you to our next speaker, who is Sarah Drasner. She's going to talk about SVG, but a little bit more about that in a minute. She comes to us from San Francisco, where she lives. She's a developer advocate at Microsoft, but she is, in general, a web developer and an absolute expert in CSS. She also runs an amazing animation workshop together with Val Head. And she used to be a scientific illustrator. So if you have any problem sketching specimen of plants or beavers or bears or whatever, insects, you should totally talk to her because she probably can give you some good hints. I will talk to her later as well. When I was snooping around the internet to find out something that is not in her bio, I found that she has a little dog, I think. And she seems to like photographing chandeliers. There are interesting chandeliers downstairs. You should totally take a photo. She's going to talk about SVG, and her talk is called SVG Can Do That, ? Exclamation mark. Every time you have a question mark and exclamation mark in the talk title, you're probably in for learning a lot of things that you didn't know about SVG yet. So if you're just using it as a boring image format, she's going to add things like physics and animation and all kinds of other tricks to it. And I hope you will enjoy. So give a very, very warm welcome and a big applause to Sarah.
All right, thank you all for coming here, especially after lunch. I know everybody's a little bit tired and stuff, but we're going to do a lot of really, really fun things today. My name is Sarah Drasner, as Eva Lotte Lam said, and I'm here today to talk about all of the things that we're capable of doing in SVG. I feel like we've really just... I feel like we've really just hit the tip of the iceberg for what we can do with this awesome medium. So the title of the talk is SVG Can Do That. Like she said, my name is Sarah Drasner. This is me as a child and my mom and also my relationship with authority. I am a senior developer advocate at Microsoft. I think SVG is a total party. You can come join the event by making your own SVG party, or you can have JavaScript be the event coordinator for you. Get it? Event. Yeah, there's going to be really bad jokes in this talk, like many, many more of these where that came from. All right. Some of you might already be aware of the benefits of SVG, but in case you're not familiar with this graphics format, let's just talk really briefly about some of the exciting things that it has available to you. It's crisp on any display. You don't have to do any kind of image replacement for different retina displays or something like that. It's less HTTP request. I always mess that one up. HTTP request to handle. It can be none because you're just putting it directly inline. That can be really, really great for performance. It's easily scalable for responsive. It's in the name, scalable vector graphics. That's really great because we're going to do a lot of cool stuff with that today. It's a really small file size if you design for performance. If you design for performance is a big part of that, so we'll talk about that today as well. It's easy to animate. That's one of my favorite things. It has a navigable DOM. That is a really cool part because if you look at like a bitmap and you wanted to move somebody's arm around or something in a photo, you'd have to trace that out and cover up the background and move things independently. But SVG can already do that. You already have these elements that are available to you to kind of manipulate and move around. SVG is drawn with math, so that means that we can do all sorts of really flexible and cool effects with it. It's easy to make accessible. It has a navigable DOM, so we can make it accessible. And there's lots of ways to do that, but I'm going to hone in on one kind of common use today. And it's fun. Remember when we used to have fun? Fun's good, right? We like fun. SVG is such a flexible medium for building websites that I could literally talk about it all day, and I did yesterday. But I've tried my best to hone it down to some things that I consider to be greatest hits. It's worth saying at this point I'm going to be showcasing a lot of things in demos today. All of the demos are open source and the code is available in the slides, which I'll tweet out later. And some of them are not by me. Anytime it's not by me, you'll see their name. I'll credit them in the slide. Okay. I actually hope that this is the last year that I have to show this slide. I think for a long time SVG wasn't very well supported, so it kind of got this reputation for being not well supported, but it actually is very well supported now. That IE 11 actually goes back to IE 9. I don't know why they don't have that, as part of the can I use table. We even got Opera Mini. We never get Opera Mini. This is so exciting. So what does scalable mean when we refer to scalable vector graphics? You can see here that we place the graphic directly inline in the HTML. It has width and height attributes, but if I remove those, it fills up the entire screen. And with a little bit of CSS, just constraining to the viewport width and height, I can make it fit within that space too. So I can make it scale to any container. I can use grid, I can use flexbox, I can use percentage. Really, the sky's the limit here. And is positioning in CSS getting you down? SVG might be your answer, especially for something that's really complex. SVG is incredible because what you saw from that last bit of graphic was how stable it was, even though we were stretching it out and there were multiple elements inside that we could target and trigger. As a side note, I did this to myself on the plane just recently. I was watching a scary movie and holding wine, and I spilled wine all over my face. Anyway. SVG allows you to create advanced type lockups that look slick and professional while still using actually accessible text. Check out how stable that is for responsive development, and you don't even have to alter it or anything at all. Which also means that in terms of animation, we can create something that's fully responsive in any direction. And because we're working within the SVG coordinate system, we don't even have to adjust our animation with media queries or anything. The animation values scale too. We can make things with media queries if we want to, but we don't necessarily have to. So these types of positioning refinements means that it's trivial to hide and display icons in whatever fashion you wish. You can use advanced techniques to kind of display many icons in the UI for smaller viewports. I made this with a tool by Sarah Swedon that helps you arrange icons in a circular format. That link in the slides will take you to that resource. And it doesn't necessarily have to be fully fluid either, right? We don't just squish back and forth our viewports. We can implement some responsive design. So let's say you have a Huggy Laser Panda factory, like how you have in real life, because where else would Huggy Laser Pandas come from? We could have this kind of view of that factory on desktop, and then we could actually kind of think about those as 3 different interlocking SVGs. So if we have all of the different interactions kind of scoped to those little areas, then on mobile we can stack, and you can see with that magenta piece, we're actually flipping it, and it's going to interlock into place. So then when we have the Huggy Laser Panda factory, we get the thing gets pandaed, and that one's lasered, and this one gets huggied, how you do, and then it stacks on and reconfigures on mobile. This whole thing is 13 kilobytes, and it works on old Windows phones and old Androids and everything. For each of these sections, I've wrapped a timeline in a function that I pause initially and I restart when I click on the bloopy bits. Bloopy bits is the technical term. For anything that gets updated, I've scoped the design along with the engineering, so I know exactly where to go for any of these sections if I need to update the design or if I need to update the code. We can also use the stability of SVG for page transitions, which I think is really exciting. So React is really awesome because it helps maintain state in a responsible manner. This is made with React and GreenSock. React coordinates the state, while GreenSock choreographs all the intermediary values. When we're showing the transition from one page to another in this app, we can use SVG to stabilize our graphics and do really interesting effects. In this example, I'm using the state with this idea of screens. So when I click on a button, we advance the screen, eventually wrapping it around to that first screen. And we can click a function every single time that fires off one of those timelines. And we hang a timeline off of that function, and we can choreograph and finely tune all of that animation. The event was just our hook. So the other cool thing that GreenSock allows us to do is clear some of the properties set inline on the elements. That clear props that you see on line 5 or so, that's what we're using there to clear off the properties to reset the whole animation. So we can do that pretty easily. Here's another one I made with Vue.js, which I love, and another technology that I love named Nuxt. Vue is a front-end framework, kind of similar to React. Nuxt is a quick and easy way to set up server-side rendering, routing, and code splitting without ever stepping out of a Vue file, just with a couple of terminal commands. It offers some hooks for page transitions, and you can see here that anytime we're moving the mountain or the type, we can change them based on the page and based on the type, so each page is a little bit different. And because we're using SVG, everything stays totally stable for mobile. If you'd like to check out the code for this, there's a repo to explore here, as well as a live demo site. And I'm showing this slide so you can get a taste for how that SVG page route animation is done. We'll specify a mode, which basically allows it to know, wait until it's done exiting that animation before the new animation comes on, that new page comes in. And then we also have that enter. We have a few page hooks. So we have enter and leave, and so I can put all of my animation logic in there. This demo from Code Drops has a really similar concept, but in a different way. The fixed content lies beneath everything. So as we move the intro content up, it gets revealed. And at the same time, SVG path data is morphed with that path data ID. This pen uses anime.js, so slightly different take on the same concept. And we have basically, if we work with this way of working, we have the same amount of path values. This pen by Sullivan Nolan, I think, is so awesome. It combines two effects, transitioning these different sections while morphing the lines. This is done with Morph SVG from GreenSock, and the effect is really captivating. Again, note the stability when we scaled it down to mobile. We can also use SVG for the layout itself. When I was working on that web animations workshop page for that thing that Val Head and I are working on, we have this branding that's triangular. So the different sections of our site have these triangles in between them. That's just an SVG that has preserve aspect ratio none on it. And what that allows us to do is basically tell the graphic, scale whichever way to the container. So if you had something like a face or something in SVG, you would never want to use this because it would get all wonky and display differently. But if you're trying to make pieces of page layout, this is actually really easy to work with and really, really fun and very, very stable. SVG can be tiny. This is one of my favorite parts of SVG. This graphic is from the I'm always going to butcher this, HTTP archive. Got it. It shows a breakdown of what kind of data is being transferred across the internet on large. So we're spending most of our performance budgets this way. And notice the images one, that giant big blue block, that's like 2/3 of what we're transferring across the internet is images. It's more than half. So I love this quote, you can't be a web performance expert without being an image expert. It's actually pretty true. If you look at all of that, I'm not even going to say the archive information, you can see how much of that was actually thinking about graphics. So know that not all SVGs are created equal. The more path points you have and the more complex the SVG is, the bigger the SVG will get. That said, if you draw things out with geometric shapes, it tends to be pretty small. Once you already have an SVG graphic, you can also make it better. There's all these tools that you can use. SVG OMG is by Jake Archibald. It uses SVGO. It also uses service workers, so whatever you use, whatever settings you set while you're working with it, it will retain that knowledge later on, so you don't have to keep resetting those controls. Pretty nice. Peter Collinridge's SVG editor is kind of like an old school Rails app that's been like experimental for 8 years. I still love it. You should check it out. And if you're more comfortable with your terminal, SVGO is the terminal-based one, but I would suggest pairing it with the SVGO GUI because the way that you optimize can actually change those graphics, so you kind of need to see what you're doing. I used to be a consultant before I just started with Microsoft a few weeks ago, and I worked with a client where their site was a really big site, and it took them 10 seconds to load the site, and by optimizing the SVGs on the site, I took it down to under 2 seconds. So that article, High Performance SVGs on CSS Tricks, kind of details some of the steps I took in order to make those graphics a little bit better. So in this pen, I've drawn a little spaceman that's standing on the moon, and the cow goes over it, kind of surprising him each time. I've used Draggable for this, and it's touch device enabled for mobile, and that whole SVG was 2 kilobytes. So while we're looking at this, let's take a gander at what's happening under the hood and a gotcha I ran into while I was building it. One thing that I was trying to do was make that cow go around and use transform origin to kind of make that happen. So I used this null object, this kind of rect, to go around, basically make it so that I could spin him on an axis, but also see if I could hit test that anytime that rect was hitting the spaceman's helmet, that it would fire that kind of animation. But it was firing all the time, and I couldn't figure out why. But what I realized was, once I started, putting these outlines on things and stuff, was that it was constantly firing because the DOM doesn't see diagonals. The DOM will only see these rectangles, no matter what's happening inside of it. So to kind of illustrate this point better and to show you exactly what I mean, I made this pen with all these rotating objects, and all of these are spinning, even the circle. I mean, look at the circle, it's so weird, come on. So just letting you know that if you are gonna play with interaction or do something that's a little bit more interesting, that's what the DOM is actually seeing. So back to the weight of SVGs, because they have the potential to be so small, it's a perfect time for a loader for an animation. I made this for Smashing Magazine's checkout experience. When they gave it to me, it was 35 kilobytes, and by optimizing it correctly, I brought it down to 6 kilobytes. I didn't draw this, I just animated it. That's including all of the animation for it too. SVGs can make other graphics smaller. There's this cool tool by Shaw, you should definitely go follow him, where he's basically using SVG's ability to mask large areas to reduce the file sizes of PNGs and JPEGs. So this is just a random image I found. I didn't particularly make an image I knew was going to be really good in savings, but that took that image from 38 kilobytes to 16 kilobytes. That's really, really cool. The potential to make things much smaller is there. So yeah, we can also make engaging graphics with the SVG itself. I was really into illuminated manuscripts, these Book of Kells initial illustrations where this is a giant T and it's really, really beautiful. And I was kind of thinking about what would happen if I tried to update that for modern times. So if I wanted to make it a little bit different for desktop and mobile, and tablet and mobile, I made this first one that's an A that I was going to animate. And then I wanted to make it a little bit less complex for tablet and also change the background, and then have this one on mobile. So I made it into a sprite because I can see that the tablet and the desktop are pretty similar to each other. I can probably slap a class on some of those and hide and reveal some information with media queries or change the background with media queries, and then change to that mobile view that was a little bit different from that. So we can change this view box, and the view box is basically how we see through that SVG. I'll talk about that a little bit more later. And we're updating that sprite based on the position of that page. And you can see the animation and all of these things update as we size the page down. And the view box shift with JavaScript is necessary. Usually we can just do that with media queries, but view box isn't something that's in CSS yet. There is a spec that's going in CSS now, but it's moving very slowly. So in the meantime, you'd have to use JavaScript to switch up that view box so that we can see the different parts of the graphic. And that whole animation and SVG was 8 kilobytes gzipped. So if you compare that to using text and images to illustrate an article, sometimes you can actually make something more engaging and more performant with something that's kind of unique. I know sometimes we think of it as oh, we're either going to make this cool thing that's animated and the performance is going to suck, or we're going to make this thing with text and images. Maybe you shouldn't be thinking that way because it's not necessarily a trade-off like that. SVG can be accessible. I mentioned this before. It has a navigable DOM. There's a lot of ways you can do it, but 9 times out of 10, this is kind of what you'd need. So we have ARIA labeled by in the title. The title has to be the first element right inside of the SVG. You also see that we have an ID on the title. We need the ID as well, otherwise it won't be picked up by JAWS and NVIDIA readers. I think that's a bug, but I'm not sure. That role of presentation is also really important because we said that we had a navigable DOM. We want it to not traverse all of the things inside of it and be nice to screen readers, so it's not announcing all those circles and rectangles and things like that. I also put the language of English it doesn't have to be English, on the title so that the screen reader can also translate if it's a different language too. This resource has, that link has a bunch of support charts, and Heather wrote an article for CSS Tricks where she went to the library every weekend and checked all these different types of SVG graphics on all of these different screen readers. It was this huge labor of love, and she didn't get paid very much for it. You should go use it because that was just like a labor of love for the community, and definitely check out that resource. SVG can be styled like text. A lot of people use SVG for icons on their site. That's probably the most common use case right now. And you should, because it's better for dyslexic people, and there's all sorts of reasons you should do that. I get like Twitter questions sometimes, and the one that I get very frequently is, I don't want to keep styling my SVGs with fill when all the text around it is using color. How can I make sure that the SVG is just picking up the color of the text around it? So this is the question that I got. I left it exactly how it was. And the secret trick here, or maybe not so secret, is that you, with any kind of fill, you use current color, and then it will be styled with whatever text is around it. So if I put this next to a bunch of blocks of text and that was colored red, that would also follow suit. I also made a couple different refinements in there and optimized it a little bit, but I tried to comment the code pretty well, so you can check it out later. SVG can bounce. So this is when we get into physics and some like really, really fun effects. We can make a ball bounce with SVG without any animation libraries, just using request animation frame. Here we have a ball bouncing, and we use a little bit of physics to update the ball bounce with subsequent bounces, or we can use its gravity, or we can change its radius. We're using Vue to update this animation midstream. So here, there's some information I'm not showing here, but basically we have the initial total height and the radius, and then we have methods that will be called to increase the height or radius as we click the button, and then we have gravity that increases the vertical speed, horizontal speed increments the horizontal position. Basically, I'm stealing a bunch of physics out of physics books to update all of the balls and make sure that it bounces and that when it hits, it reverses that kind of gravity. So then we're also going to change that button based on whether or not the animation is running. I think that's really legible and fun. And then we get to use request animation frame to use that bounce ball that you saw in the last one. This pen by Tiffany Rayside is one of my favorite animations of all time. She's not using any library or anything here, and she's spinning up pieces of SVG. And check out how she manipulates that path data to get a realistic bounce when it flies against the walls, and you can even update all of the vertices and points. She's really a master, so you should definitely go follow her on CodePen and just like check out all of her amazing stuff. SVG can snap. In order to create advanced effects with SVG paths, to make them snap, we're going to use ES6 template literals. I mentioned that you can manipulate path values in the last example, and that kind of manipulation is supercharged if we think of those big strings as something that we can update really easily with ES6. So before ES6, if you're not familiar with it, if we wanted to manipulate strings, we'd have to use string concatenation, and this way of writing was really arduous and a little bit error prone and not that human readable. All of that would like result in something like this. But now with ES6, we can refactor the above and pass in variables really easily, and it's much more legible. It makes our lives as devs much easier. Most of SVG path values are these strings that we're just updating, and if you understand those curve commands, you can update those as well. So what does this have to do with SVG? Well, aside from platonic shapes, SVG offers different curves and line commands so that we can make complex shapes with a small amount of code. And this is a cool pen by Anthony Dubois, where he allows you to explore different paths so you can kind of go through and work with those different curve commands. I also have a book that breaks these down if you need more info. If you want to know how those curves are made, then you can start to understand how you can manipulate them and make things like a slinky. So when building out these reflected path curves, we'll start with an M, which stands for move to, and then we have a Q here that has a reflected cubic Bezier. So we draw one point and then another point, and then the computer draws a curve. How cool is that? I just think that's so rad. Like, you have this point, you have another point, you have another point, and then the computer's like, I got you. And all of a sudden we can make these complex shapes with like 4 lines of code. Not even 4 lines of code, like 4, pieces of numbers, basically. So we can use that concept and some regular old JavaScript to plot the points initially, and we're going to start with an L, which will make a line, and then eventually update them to a Q. And the points in between are really flexible. So we can make effects like this, which is a snapping piece of yarn to celebrate the yarn release. SVG can distort. In that last pen, I'm doing some like weird distortion effects at the last part of it, so let's kind of go over that really briefly. SVG has this thing called filters. There are contrast filters, there are blur filters, there are distortion filters, you name it. You can create so many really advanced effects with them. There was a post on Code Drops where they had a lot of buttons, and one of the coolest buttons was one that you clicked and it had a ripple effect. So I did something similar with this ripple effect, but before I show you the demo for that, I just want to show you that manipulating filters are kind of performance insensitive. You're not really supposed to manipulate them. I'm kind of hacking this. It's not an animatable property. Animatable? I think that's a word. So what I do is I have these helper functions that will basically set the filter exactly when I need it and then rip it off as soon as I'm done so that it's not taxing the rest of the site or any of the other performance. So we can make something like this, which is a ripple in a pool. So that's pretty fun. And the way that this is done is by applying that filter along with this image that looks like a ripple. So we can animate this filter, and basically what we're doing is moving it backwards and forwards and scaling it as we do so, and then it will distort all of the things that are underneath it. So we can also make things like this globe. I think in the current political climate, this wasn't like a really good choice. I didn't really intend that, so I'm sorry about that, the timing for that one. We can also animate filters to create advanced effects like making a candle built out of math. I think that's just like so cool that it's that flexible of a medium. It's not just, these flat geometric shapes. So in order to make this, I made a candle with a bunch of different flames. They're not actually those colors, I just colored them like that so you can see each piece of them. And there's little pieces that are kind of floating up, and the background has this ellipse that's kind of glowing, getting bigger and smaller. And the bottom pieces are just like 2 different paths that have 2 different gradients on them that are next to each other. And I'm using this GUI effect that actually Lucas Beber kind of invented. He basically combined a contrast filter and a blur filter. It makes this cool GUI kind of thing. You can apply it to HTML elements, which is what he's doing here. You should go follow him too. He's brilliant. He has a lot of really, really cool pens. So I'm basically using that to my advantage here. And so with that candle, you might notice when you look at a candle, it doesn't stay the same kind of consistency. Sometimes it's really, really solid, and then sometimes it gets kind of like mushier or something. So I'm actually animating the standard deviation of that filter, which I'm, again, not supposed to be doing. And then it can kind of come together and fall apart. I've also got a for loop here where I'm morphing those different path values, those different like candle flickering shapes, and I'm plotting it along the timeline using that same for loop. So we can use the same technique to create things like smoke with math. We can also use SVG to make on-the-fly logo adjustment. This is so cool. So you don't have to go back and forwards with your designer, like, maybe you put another logo in. No, that's not what we want. We're updating the logo again. It's going to get smaller this year. This demo was made by Leah Veru, and if you don't already follow her, you should definitely follow her. She's amazing. Check out how flexible this logo is. By the way, if you want to, you can also leverage her tool here. It's called Mavo. And it allows you to make complex sites without any JavaScript, just basic HTML and a little bit of CSS. So you know how your family members are probably constantly like, hey, can you make this website for me? This might be the right tool for allowing you to do offload some of that work so that they can actually make those sites themselves. SVG can also draw itself. This is a really, really cool part. So imagine we have a shape, and then that shape has a stroke that's dashed. But that dash is really long, and it covers the entire shape. But the other piece of the dash, remember, was that offset between the other dash. So there was the dash and then the spot in between the dash. And so that point, that spot in between the dash, is an animatable property. So we can actually make the whole thing draw on. So we can do stuff like, this is, to celebrate New Year's, I made this, and we can do Happy New Year's, and then we can make them fall, and then some fireworks. I don't know why I'm narrating this, you can see it. So that's pretty fun. Chris Gannon did this awesome pen that uses the same technique with a clip path to reveal different information. Holy cow. He's amazing. Definitely go follow him. He has a million amazing SVG animation demos. You can interact with an SVG. So we can manipulate and interact with an SVG on the fly. That's really fun because we can make all sorts of, crazy effects really, really fast and really, really easily. We can change, have the user update the colors and really, really give that ability to update it back to the user. But it's still a graphics format. So even though we're updating it and we can change the animation, we can make small circles and big circles, we can also allow the user to download it. And while it's updating and animating, it's changing in position. If we open up that SVG graphic, it's respecting exactly where it was in that animation too. So that is really, really cool for being able to make things on the fly and give the power back to our users. So here inside the HTML template, we can create some semantic form elements, and the button click will bind to a method that we define in a Vue instance. In the create big circles events, we're going to get the reference for the SVG in the correct namespace, spin up some circles using some helper functions that I call totes rando because I'm a nerd. And to create the animation, we do something very similar. Here we have some form elements with the buttons that play and pause the animation, and then we can begin an animation timeline or pause it depending on the interaction. We can also use SVG to respond to something like a mouse move. So here Wally's trying to find his cockroach friend, and he's kind of reaching out for him and responding to him moving across the page and yelping and stuff. So Vue makes it incredibly easy to kind of marry these two things. So having these mouse move events move across the page, and I'm capturing those coordinates. And there's a bunch of code I'm not showing here, but basically the way I made this is he's kind of constantly moving around in this other animation timeline. But there's one animation timeline that I make where he just stretches out his arms, right? And then I pause that animation and plot the progress along with the coordinates of the page. So as it moves, as you move that mouse cursor, he is actually literally moving along with that animation. So the animation's all done and everything, but we can plot that along with interaction and even have him change directions. We're just flipping him over. So SVG can also be clipped and masked. We can show different pieces of the SVG depending on your needs. So with Wally, I needed him to be able to stretch his arms out but obscure some of the information of his arms as he was doing so. Otherwise, I can't just tuck everything back there. It's a little too complicated for that. So what I did was make a clip path that's just a little circle there, and it allows me to kind of stretch those arms out and obscure anything when he starts tucking his arms back in. So that's really important for things like realistic movement. Clipping will cut off any element based on its geometric shape, but masks will reveal opacity. So here we've created some masking with a GIF, and we're revealing this SVG pattern that we made. So you can do any kind of GIF masking or other kinds of shape masking to show and hide opacity as well. So we create a mask in defs, and within it place the image that we want to use. Then on the rectangle in the image, we place the mask and the pattern. So both of those are coinciding on one rectangle at the same time. And I learned this technique from someone named Yoxel, who's a brilliant front-end developer. She has a whole slew of pens like this that are so awesome and really, really cool to explore. She also made this amazing reference pen, which is the most comprehensive tool I've ever seen to explain clipping and masking. It's like all the SVG clipping and masking and all of the CSS clipping and masking and like support tables and everything. So that's a really, really good reference. I also wrote a CSS tricks article because I kept getting confused between the difference between clipping and masking. I'm like, I just want to be able to search the internet and find this. So I wrote that up, so you can find it now too. Since SVG has text, we can even apply some of that crazy GIF masking to text, and the text can be editable. So we can change the text on the fly too. And this is one of my favorites. This is kind of a famous pen by Noel Delgado, and it's a great example of clipping and masking to show and hide and reveal information. You're showing pieces of that skeleton. SVG can signify something changing. It can allow the users to understand that something is updating in time. So I kept going in between different time zones. I'm like flying back and forth to Europe a lot and stuff. So in order to understand where all of my, or when, all of my coworkers were, I made this time zone changer kind of thing. And that graphic is basically there to allow you to understand how close to day or nighttime you are as the dial kind of updates too. So the cool thing about this actually didn't end up being the SVG at all, but that I figured out that I was using moment.js for a lot of my daylight time savings, kind of understanding time zone informations, and it's a pretty heavy library, but there's actually a native method called toLocale timestring that you can pass, so you can remove a big library like that and only use just a couple lines of code to consider daylight savings times in different time zones. So again, I'm using Vue here, and in my methods, I'm getting the current hour by passing in the zone, and I like this method because there's a lot of options to format that the way that I need. You can also use an SVG, the SVG's view box like a camera. We kind of glazed over an SVG view box right at the beginning, so let's dive into that just for a minute here right at the end. So I drew this graphic of a pagoda and some cows and some houses and a starry sky and stuff. But when we're talking about SVG, and when I say that it has a coordinate system, really what you can imagine is that it's like a piece of graph paper. And if you've ever played something like Battleship, it's basically those coordinates. You're basically saying like C2 and then plotting that point, and that it's not literally C2, but I'm talking about Battleship. And that's how we're drawing all of those pieces. But that piece of graph paper is infinite. It can be just giant, and there can be shapes anywhere inside of it. So what the view box allows us to do is peer inside and say, draw that camera, like see inside of that graph paper right here. So what it has inside of it is 4 values. So we've got the 0, 0, which is the x and y coordinate to start off with, and then a width and a height. That's what those 4 values that you'll see inside of a view box is. So if we look at this little scene, if we wanted to update the view box to say those houses, we could redraw them and say, okay, x and y are at 215, 160, and the width is 42, and the height is 20. So SVG has a native method called getBbox, and when you console log it, it returns this thing called SVG rect. So if I console log this getBbox from any path or group or anything, it will return x, y, width, and height. That's kind of cool, right? That's like exactly what we need to update a view box, so we don't even have to find it manually in the DOM either. So if we want to update something on the fly, like this graphic, if I comment this all out, you can can see the whole graphic there. But in order to update it, it's not much. It's just basically updating those values inside of the view box. So then we can animate them for things like data visualization. So if we have something like a big map, we don't have to show completely different views. We can actually zoom in. And it's SVG, so it's great for mobile as well. So we can show and hide different information. We could also make something like a flow chart. If we have a lot of information and we want the user to be able to control where they're going and what kind of information they see, I made this like, what graphics format should we use? And then it goes to a CSS Tricks article for depending on how you answer that. There's also this pen by Andrei Sorokin, where you're basically playing this game of like, placing these different things inside the house, and the view box updates to the different areas in the house depending on what you do. So we talked a little bit about how SVG can make a game. So the last thing we're going to do today before I let you go, and it's really hot in here, is we're going to make a game. So let's say you're a hipster elephant and you're trying to go get tacos with your friends, but they keep texting you and trying to change plans. This is based on a true story. And you're kind of like going through space and trying to get the tacos and trying to avoid these text messages. Oh, margaritas are extra points. Those are really cool. So you're kind of going back and forth, and there's that heart meter there that's going to say how much health we have based on whether we're getting tacos or text messages. And I'm basically probably going to lose in a second. I'm definitely going to lose in a second. And we lost. We were overruled, didn't get to eat any tacos, and we're going to be hangry and watch a movie we already watched instead. And if you win, you get to tweet out your score and things like that. So how do we use SVG to build this game? We used it 3 ways. We used it directly inline for loops for things like the clouds that were moving around. We used it for background images for things like the tacos. We weren't really manipulating the tacos. They were just getting thrown across the screen, so we don't need to do much with them. And then we had things directly inline in React. We built this game with React because it coordinates state really well, so we could have used any kind, we could have used Angular, Vue, React, what have you, and marrying those graphics with SVG, there's all this cool stuff we can do. But I'm going to zoom in on one thing in particular, that heart meter that we saw. So if we have an initial score of 500, because we don't want them to be like winning or losing, we want them to kind of be in the middle there, then we can have this score that's going to update depending on, we're going to see if they're like starting the game. So if they're just starting the game, or if they press replay, it goes back here. And then we update the score, so we're checking it to see if they won or lost. And then we're going to pass this, the rectangle didn't make it down to the heart meter. It's supposed to be eliminating the heart meter. So we're passing that score into this heart meter component. And if we look at the heart meter component, it's really just an SVG, and it just has a little rectangle with this width on it. And that score is getting passed down to the width. And remember, we're using SVG, so it can be any size. So I'm actually using full numbers. It's going to be, 1,000 or whatever, but because it's SVG, it doesn't matter. I can just scale it down to be the appropriate size. I can update it on the fly. So on desktop, it's a little bit bigger. On mobile, it's a little bit smaller, but it's not actually 1,000 pixels wide or anything. But we can use real numbers to update it. So if you're not familiar with how rectangles are drawn in SVG, it's kind of similar to that view box where we have an X, a Y, a width, and a height, and we can update it really, really easy on the fly. We can also use the bounding client rects. Remember when we were looking at that bounding client for the circle and the star when they were rotating? We're going to see that they're going to fly across the screen. We're going to detect if they hit each other, and then we're going to fire a timeline and some noises and things like that every time they do so. All of this, and we didn't even get to data visualization. There's just so much to explore today. And also, Nadi gave a great talk about SVG and data visualization right before mine, so if you missed that, you should go watch that Vimeo later on. I wrote an O'Reilly book about SVG animation. This is not my book. I don't have the man blob animal. This was my friend trolling me. That's not even my last name. This is my book. I think I have a fancy chicken or something. It's available if you want to check out more stuff that you can do with SVG. Thank you so much for having me today.
Thanks again, Sarah, for giving an amazing firework of a talk with lots of useful information and beautiful pictures. If you have any questions for Sarah, just come and find her during the day and also all day tomorrow and ask your very specific SVG and other questions directly.